Hello everyone, welcome back. In this video, we'll be discussing about the third problem of today's weekly contest, minimum cost to convert string 1. The problem is a bit easier than the usual third problem, so at the end we'll be discussing two follow-ups as well. If you are here just for the follow-up, all the timestamps are there in the description down below. You can move to the section you like without watching the previous ones. So with that, let's get started. The problem states that you are given zero index string source and target both of equal length. You are also given a zero indexed character array, original and changed, and a integer array cost. Basically, the cost of changing original of I to changed of I will be cost of I. Now you need to return the minimum cost to convert the string source to the string target using any number of operation. If it is impossible to do so, you have to return -1, right? So let's take an example. Let's say source is abcd, target is acbe. This is the original array, this is the changed array, and this is the cost array. What this means is, to convert a to b, you will incur a cost of 2. Similarly, to convert b to c, you will incur a cost of 5, and so on and so forth. So you need to return the minimum cost to convert this string abcd to acbe, and if it is not possible, you have to return -1. So in this case, the first character is matching, so we don't need to do any conversion. Then b is not matching with the second character, which is c. So there is a character b in original array which can be changed to c with a cost of 5. So we'll do that. We will just change the b to c with a cost of 5. Similarly, we have to convert c to b. Now in this case, you can see there is a character c here which can be changed to b at a cost of 5, right? So you can convert this c to b at a cost of 5, or one of the optimal way could be you convert this c to e first, and then you convert this e to b, right? And if you do that, you will incur a cost of 1 plus 2, which is 3, which is less than 5. So we'll do that, and we'll convert this character c to this character b with a cost of 3. Note, you can use as many operations as you want. You don't need to minimize the number of operations. That's why even though we have a direct path from c to b, we took a indirect path wherein we first change the c to e and then from e to b, right? Because that is incurring us minimal cost than the previous one. So we changed b to c at a cost of 5. We changed c to b at a cost of 3, and then from d to e there is just one path, d to e, which has a cost of 20. So we just use that. At the end, we incur a total cost of 28 to convert abcd to acbe, and hence the answer here is 28. So hope the problem statement is clear. Now how to solve this? So this is your original array, and this is the changed array, and this is the cost that you will incur to change this character to this character, right? Now we already have seen that even though we have a direct path, it might happen that indirect path may help. So let's just look at it one more time. Let's say you have to convert this b to c. So in this case, there is no direct path from b to c at all, right? So but you can see there is a path from b to e, and then there is a path from e to c, and this is what makes this problem a bit harder, right? Because you don't have to just look up this particular mapping and substitute the values. Instead, you have to combine these lookups in some way that can give you the desired result. So If you think about it, we this is representing a graph, right? We have to, like, we have been given that we can go from A to B, we have been given that we can go from B to E, so we can go from A to E as well with 2 plus 5 cost. So we have been given this, we can represent this entire thing as a graph. So let's say you represented that as a graph, so this is how it will look like. Now in this graph you want to know what is the minimum cost to go from, let's say, B to C. So what you can do, you can simply apply any shortest path algorithm and figure out what is the shortest path from B to C. Now after you figure out that, you know how much cost will you incur to convert this B to C. Now you will say, okay, how much cost I will need to convert this C into B. Again you will do the same thing, you will take this one as a source, this one as a destination, apply any shortest path algorithm and figure out what is the minimum cost required to convert this character to this character. So you can keep on doing for all the characters and finally you will get the answer, right? So that's the very brute force solution that you can have. Now what is the time complexity of the entire solution? Time complexity would be what you are doing something for each of these characters, right? In worst case every character is different, right? So you will be doing something for each of these characters. So let's represent this as n. The value of n is 10 power 5. So we are doing something for each of this character, and after what we are doing, we are applying a shortest path algorithm from source to destination, right? So if you apply Dijkstra, complexity of Dijkstra is e plus v log v, right? So basically in this case v is the number of characters that you have. So this v is nothing but 26. So the value of n we just saw is 10 raised power 5. Value of e, which is the number of edges, so number of edges will be how many, the size of this cost array, right? So let's just represent this with c, the size of the cost array, which is 2000, right? So let's just make it 2000 here, right? And finally v, which in this case is 26 because we just have lowercase English letters, so number of nodes in worst case will be 26. So if you multiply them all or put this in this equation, you will be getting 10 power 5 multiplied by approximately 1000 multiplied by log of 26, which is again a constant, so just ignore that. So even if you multiply n with e, the complexity will not fit in the given time constraint. So this solution, this brute force solution will not work. You have to optimize this. Now how to optimize? Think about it. Let's say you want shortest path from B to C. Now there is another node which says I want shortest path from B to, let's say, F, right? So when you apply Dijkstra, you get shortest path from one source to all the destination, right? So with just one Dijkstra you can get the shortest path from one source to all the destination. So why you are applying Dijkstra repeatedly whenever B occurs? So we can optimize that piece for sure, because we don't need to apply Dijkstra from scratch for all the scenario where B is the source, right? So that's basically the optimization part. So let's say you apply Dijkstra once for each of the source. So there are 26 sources, right? At max. So you are applying Dijkstra 26 times. So after you apply Dijkstra, you will get the shortest path from A to everything, from B to everything, from C to everything, and so on and so forth. So you will apply Dijkstra 26 times, and applying Dijkstra, we already discussed, will take this much time, right? So let's just get this here, and after you apply Dijkstra, you will then just do a lookup for each of the character, right, and see what is the minimum cost required to convert from source to destination. So now this is your overall time complexity, and this will give fit in the given time constraint for sure. Why? Because 26 into 2000 into some constant, this is okay with the given time constraint. So let's just do a quick dry run, and before we get into the coding piece, uh, so if you see, we will apply Dijkstra for every source. So we'll start from A, we'll apply Dijkstra, and after you apply Dijkstra, you will get shortest path from A to B, A to C, A to D, and A to E. So let's say you have applied Dijkstra already, and this is what you get. You know that the shortest path from A to A is 0, A to B is 2, A to C is 9, A to D is infinity. Basically, there is no path from A to D at all. If you see, you can't go to D. D just has one outgoing edge, so there is no incoming edge, and hence you can't go to D at all. And hence, if you look at this, the value to D is always infinity, except D because that's the source. So once you apply the extra, you will have something like this. Again, to get this entire thing, you have to apply the extra 20th number of times, and each time you will be spending this much number of time to compute this one array. So this is the overall complexity to compute this array. Now after you compute this array, everything else is simple. You will just iterate over it. You will see, okay, I need to convert B to C. So I will go to the source B array and see what is the minimum operation to convert from B to C, and you will suggest do 7 plus 7 in your answer. Similarly, you have to convert C to B, so you will go to C, see the number of operations required for B, add it to the result. Finally, you have to convert D to E, so from D to E, 9 operation, right? And from B to F, so there is no F here, so they just for now let's remove this one completely. So this is your overall minimum operation, minimum cost required to convert one the given source string to the given target string, right? So hope this entire solution makes sense. If you have watched this point, I would strongly encourage you to code this entire thing yourself and get it accepted as well. Again, you don't know Dijkstra should not be an excuse to code this out, because you can just think of Dijkstra as a black box, just like you don't code AVL tree but still use set, right? So think of it like this, just copy paste Dijkstra code from somewhere. You can use mines as well, and code the rest of the piece by yourself without looking at the code. So next we'll look at the code before jumping into the follow-ups. The code is exactly what we discussed. We prepared our graph. After preparing our graph, we applied Dijkstra for each of the nodes. After we have Dijkstra, we just iterated over the source and see which character I need to convert it to, and I will just look at the value or the shortest path from that particular source to destination. If it doesn't exist, I will return -1. If it exists, I will add it to the result and finally return that as an answer. Now this is the Dijkstra part, which is again the standard process. We initializes our cost vector to infinity. Only cost of source is 0. Basically we are starting from source and we don't know the cost to any other vertex, and hence everything else is infinity. Now we put everything in the set. You can use priority queue as well. Everything is same. So the main motive is to have a data structure that will give you the minimum element in just order log n time, and that can do insertion as well in log n time. So set and priority queue both fall under the same category. So after this, I just popped out the one smallest node from the source, and I iterated over all the children, and if the path already known path to children is has greater cost than going via the current node, then I will update the path of that children. So I will erase the previous one and I will insert the new one, right? So we'll keep on doing this, and finally this cost array will have the minimum cost from source to all the destination, and finally I will just add it to the like persist it in the path src, because I will be querying that particular value at the end, right? So hope this entire solution makes sense. Now comes follow up. So follow up one, let's say cost dot size is less than equals to 10 raise 6. Let's add one more zero here, sorry. So let's say cost of size is 10 raise 6. Now will the previous solution work? The answer is no, because previously, if you remember, this e was the cost dot size, right? So 26 multiplied by 10 raised power 5 or 6, whatever you said, and then multiplied by some constant factor. So this will surely not pass, and hence you have to optimize this. Now I would encourage you to pause and think about this follow up by yourself for few minutes. So hope you have thought about it. The solution is very easy. What is this cost array denoting? The cost array is denoting what is the weight, or what is the edges in the graph, right? Or what is the weight of the edges in the graph. So, or in other words, how many edges are there in the graph. Now think about it logically. How many edges can be there in worst case? Number of edges. In worst case, this graph is fully connected. If it is fully connected, every edge is connected to everything else, right? So what is number of vertex in this node, in this graph, is 26. So maximum number of edges could be 26 square, right? Of the order of 26 square. So this is the maximum number of edges, and if you like compute it, it will be somewhere around 4 to 500, right? So the value of cost, the size of the cost is 10 raised power 6, only means that this has duplicates. Basically there are two things, a to b is repeated somewhere here afterwards as well, so it contains duplicate. That's why the size is larger. And if there are duplicates, how will you tackle this? You only care about the minimum one, right? You don't care about the let's say this is also a to b, right? And the cost of this is 9. So among all a to b, you only care about the one which is the minimum cost, which has the minimum cost, because at the end you need to find the minimum cost. So you can dedupe most of them and reduce the size of this cost to just 26 square, which is less than even 2000, right? Which is given the problem. So we can reduce this cost size by deduping, and after that apply the exact same algorithm, and it will all work, right? Now comes follow up 2. So let's say you don't have to minimize the cost. Instead you have to minimize the number of operation and return what is the cost required, right? Previously you have to return the cost required, a minimum cost required to convert ABCD to ACBE. Now you need to return the cost required if you minimize the number of operation. Okay, you don't have to return the minimum number of operation. Instead you have to return the cost if you converted this in minimum number of operation. So let's just take an example. Let's say this example only, ABCD to ACBE. So let's say you convert this B to C. So there is no direct B to C edge, or let's look at this. There is no direct B to C edge. So one way could be you go from B to E and from E to C. So basically you require 2 operation to convert B to C with a cost of 7, right? Now C to B. So C to B, either you can take this route or you can take this route. Obviously this route has minimum cost, and we previously had taken this route, that's why the value here is 3. But now we need to minimize the number of operation. So even though the previous path has the larger value, we will choose that and say we just have one operation to convert from C to B with a cost of 5, and finally from D to E there is just one operation with a cost of 9. So what we need to return is this 7 plus 5 plus 9, 21, instead of this 4, right? So this is the problem statement. Again, this is not that difficult, so just pause and think about it for a moment. So hope you thought about it. The solution is straightforward. Basically, we still need minimum path from B to C, but now the cost of each path is not determined by what is the weight assigned to it, but rather how many hops do we take. So in other words, you can convert the cost of every edge here to just one, and then apply Dijkstra to figure out the minimum cost. Now only thing you need to take care is, while you apply Dijkstra, you have to keep maintaining this cost as well. You have to maintain these operations anyways, because that's the base thing which Dijkstra will work with. Or in other words, this cost array of Dijkstra will be filled up with the operation part. So you have to maintain another array which will keep track of the weights part as well, because that's what you were caring about at the end, right? So that's basically it. If you are new to this kind of thing, I would encourage you to code this entire thing by yourself, even though you can't submit it here, but try to code this entire thing by yourself. That will give you much better clarity. If you want a validation, you can paste the code in the comment section below. I would be happy to verify. So with that, if you have any doubts, feel free to post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. I will see you in the next one. Thank you.